This is 1.6, and 1.6 is the properties that we use to help us simplify down expressions. We're going to list all the properties one at a time. We're going to talk about each one with examples, with numbers, and with variables. And this, by the way, is on page 84. We are going to go through them one at a time, and we'll talk about what each one is and how they work. And in many cases, you use these properties, multiple ones together, to simplify down an expression. So we've got the commutative property, the associative property, identity, inverse, and the distribution property. So we're going to start off with the commutative property. And there's a multiplicative commutative property and a division commutative property. And this is 1.6. And we're looking at the different properties. We're going to go through each one of these properties. We're going to look at examples. Okay, let me get the autofocus fixed here. Sometimes it doesn't want to focus correctly. So let me try to adjust this back again. Okay. I think that's going to be about the best I can get it. Okay, so we're going to be looking again at 1.6, and we're going to be looking at the different properties. So the first one, and these are on page 84. The first one is the commutative property. Now, commutative property works with the order. So commutative property is all about the order. And we have a multiplicative one, and we have an additive one. A plus B is the same as B plus A. Now, what does that mean with numbers? Let's look at it in terms of numbers so you can see they're the same. 9 plus 4 is the same thing as 4 plus 9, right? Yep, thank you for closing the door. So when we look at this and we talk about the commutative property, we're going to be looking at the order. So if you change the order, you're using the commutative property. And we know that 9 plus 4 is the same thing as 4 plus 9, right? We can flip that order. We understand that. It works with variables as well. 8 plus x is the same as x plus 8, right? They're the same. What is the only difference between the left side and the right side? Order. So that is your additive commutative property. When you switch the order, that is commutative property. Also, it can be done with multiplication. A times B is the same as B times A. Well, what does that mean? 4 times 5 is the same as 5 times 4, right? These are the same. These are examples. 3x is the same as x times 3, right? These are the same. All we did was we changed the what? Order. So anytime we mix up the order, that is the commutative property. Now the associative property, what we do with the associative property is we switch the groupings. That's our next one. So the associative property, we work with the groupings, what's grouped together. We don't change the order. All we change is what is grouped together. So 4 plus 8 plus 2 is the same. So 5 plus 8 plus 2 is the same thing as 5 plus parentheses 8 plus 2, right? So look at what we did. Did we change the order of the numbers? No. 5, 8, 2. 5, 8, 2. What did we change? We changed the groupings. 5 and 8 were grouped together with the parentheses. On the right-hand side, the 8 and the 2 are grouped together with the parentheses. We did not change the order. Okay, let's look at another one. How about 7 plus 2 with parentheses minus 3 is equal to 7 plus parentheses 2 minus 3. Why is this associative property not commutative? It's going to be the associative property because I did not change the order, did I? All I did was what? Change the parentheses, where the parentheses lie, but everything else stayed the same. The associative property can also be done for multiplication. 4 times 3 times 2 is the same, and that's a multiplication dot there. It's going to be the same as 4 times 3 times 2 at the end. You can change the grouping. I did not change the order. So when we talk about the associative property, we are looking at the grouping, not the order. Students get mixed up, the associative property and the commutative property, more than any others. So here's going to be 2 of them, and you're going to tell me if each of these is the associative property or the commutative property. Because students struggle with these properties more than anything else. How about 4 minus 3 plus 7 is 4 plus 7 minus 3. Okay, so associative or commutative, which one and why? Commutative, right? Because we switched the order, didn't we? Right? Everything stayed the same. That 3, it had the negative, so it still got the negative with it. The 7 was positive. The 4 is out in front. What did I do? All I did was I switched the 3 and the 7. I switched the order, right? So this was dealing with order. So since you moved the order around, this would be commutative. Order is dealing with the commutative property. Which one would this one be? This one would be the associative property. Why? Yep, I didn't change the order. The order stayed the same. I changed the grouping. So we're looking at the associative property here. And why is it the associative property? Because the order stayed the same. Okay, the order didn't change there at all. So this one would be the associative property. Because the order did not change, this one would be the commutative property. So if the order changes of the terms, then that's commutative. If we just switch around the groupings, the parentheses, then that's the associative property. The next one is the identity. So we talked about the associative property. We've talked about the commutative property. Now we're going to talk about the identity. And the way I remember is the identity is the same. When I think of identical twins, what do we know about identical twins? They're the same. So, when we talk about identity, we can add 0 to a number and it doesn't change it, right? Identity means they're the same. So when you add 0 to a number, it doesn't change it. A plus 0 is still A, right? So here's some examples. 7 plus 0 is still what? 7. 8 plus 0 is still what? 8. And even x plus 0 is still just x. Okay? They are the same. Adding 0 makes them the same. Doesn't change them. So when we add 0 to something, it doesn't change it at all. It keeps it the same, right? Identity means the same. What also works? Well, when we look at multiplication, we have to be careful because it's not just 0, it's 1. Because when we look at multiplication, a number times 1 is still what? Itself. So A times 1 is still what? A. 8 times 1 is still what? 8. You can use parentheses if you would like, or just use a multiplication dot. Remember, they are the same. So 9 times 1 is still what? 9. When you multiply by 1, it stays the same. So your additive identity is 0, because when you add 0 to any number, it stays exactly the same. When we multiply by 1, that's your multiplicative identity. And when you multiply by 1, what happens with it? It stays the same as well. Okay? Next, we're going to look at the inverse. Now, what does inverse mean? Inverse means the opposite. Let me write it up right here. So when we talk about the inverse, we're going to be talking about the opposite. Now, we have an additive inverse and we have a multiplicative inverse. The additive inverse is the negative. So A plus a negative A is 0. Has to equal 0 for the inverse. Inverse means the opposite. And it's going to equal 0. So 7 plus a negative 7 is what? 0, because they're opposite. What is the opposite of 7? Negative 7. What's the opposite of x? Well, the opposite of x would be what? Negative x, right? So when we talk about inverses, we are looking at the opposites, and that's your additive inverse, is they're the opposite. So whatever number you have, you change your sign. What's the opposite of a negative 8? The opposite of a negative 8 would be a what? Positive 8, right? Because they equal what? 0. So they have to equal 0. And they're different signs. So inverses, they equal 0, and they have different signs. That's for your additive one. For your multiplicative one, you use the reciprocal. Okay, so we talk about additive inverses, you just change your sign. These are additive inverses. Multiplicative inverses, you flip the fraction over, use the reciprocal. So for multiplicative inverse, we use the reciprocal. That means you flip the fraction over. So for a multiplicative inverse, you have a, and the multiplicative inverse would be 1 over a, and that equals 1. Here's some more examples of the multiplicative inverse. 8. What's the multiplicative inverse of 8? 1/8, because they go together and they make it what? 1. What about 5/9? What's the multiplicative inverse of 5/9? 9/5, because they go together and they make it what? 1. So when we talk about the multiplicative inverse, it must equal 1. So you have an additive one, and you have a multiplicative one. The additive one works with the signs. The multiplicative one works with the reciprocals. We could even use a variable. But with the multiplicative reciprocal, the multiplicative reciprocal of x be, well, that would be 1 over x, right? Because those come out to give you what? To give you 1. These are called inverses. So either it's the opposite in the sign for the additive inverse, or you flip it over for the multiplicative one. That was for the identity. Or sorry, that was for the inverse, right? We talked about the identity. So these are the inverse. Now let's do the last one, which is the distributive property. Now this is the one we've used all the time. We even say the name. The distributive property is when you distribute or you push something through. Okay, 5 times 3 plus 7. We can use our distributive property and distribute that through, and that would be 5 times 3 plus 5 times 7, right? That's the distributive property. It works the same with variables. 4 times 2 plus x is the same thing as 4 times 2 plus that 4x, right? Because you can distribute that 4 through. When we draw our arrows, we use what's called the distributive property. And by the way, this can be split up because 4 times 2 is an 8, and that would make that then a 4x. What about this one up here? 5 times 3 is a 15. 5 times 7 is a 35, and then you could combine them together, and that would make that then a 50, wouldn't it? So that's the distributive property. Whenever you distribute or push through, that is using the distributive property. Now I'm going to put several of these up, and you're going to tell me what property we're using when I rewrite it. Okay, so you're going to tell me if it's inverse, identity, the distributive property, the associative property, or the commutative property. What would this one be? Inverse. Why is it going to be inverse? Because they're opposites of each other, right? And what does it equal? 0. So this is the additive inverse. What would this one be? What did I do? I changed the what? Order, right? If I change the order, then what is it? It's not associative would mean grouping, right? I'd have parentheses. Do I have any parentheses here at all? No, this is just changing the order. So this is the commutative property. Right? Why is it commutative property? Because I changed the what? order. 8 plus 2x is going to be the same as 2x plus 8. All I did was I switched the order. When you switch the order, that is the commutative property. What about this one? Yep, so, and we don't have to say multiplicative inverse, we just say the inverse, right? Because they're the opposite. There's a multiplicative inverse, and there's an additive one. This one is the multiplicative inverse. Why? Because when I take 9 and I flip it over, what does it become? 1/9. What would this one be? 3x times 1 is 3x. Did I change it at all by multiplying it by 1? No. When I multiply something by 1, does it change it at all? No. So this would make it then, you're correct, this would make it then an identity. Let's do one more. What would this one be? Does anyone have any idea what this one would be? Okay, what did I do? I added 0, right? When you add 0 to a number, does it change it at all? Nope. So this one would also be identity. And just to make sure we know the associate, let's do one of it as well. Why would this one be associative and not the commutative property? You did not change the order, right? So the order is the same. If you don't switch the order, then this would be associative. If the order stays the same, just the groupings, that means we're using the associative property. So we're going to associate them differently. The way I remember associate is just group them together. Okay, so I changed the groupings there. Now we're going to work with some of these properties, and I can show you how you can use them to make it a little bit easier. We can do this mentally. I'll just pick a couple of these, and I'm going to show you how I would just do these mentally. Let's look at 44. We can use these properties to work this one out mentally. You don't have to. You can use a calculator, but let's say I just don't want to, and I just want to do this quickly and mentally. What do I know? Okay, I can switch the order around because I can put those two together. And what did I do? I used the commutative property, right? Why is it the commutative property? Because I switched the order. Why did I do that? To make it easier. Because now I know that 49 plus 1, what is that? 50. And 199 plus 1, that's 200. And now I can mentally add those together, and that makes it what? 250. Now you could have just used a calculator and added them across. But let's say I just wanted to do it quickly and easily mentally. Well, 49 and 1 is 50. That's easy. 199 and 1, I can switch that around. That's 200. So that's easy. Add them together, you get 250. And what property did I use? I used the commutative property. Okay, let's try one now with multiplication. Okay, let's look at, how about question, Let's see, how about question 51? We can use the commutative property on 51. The same way. So all I'm going to do is I'm going to rewrite them in a different order. So this is going to be the same as this. I just switched the order. Why is it switching the order going to make this easier? Because 5 times 2 is what? 10. And 10 times 47 is easy enough. That's 470, right? You can just easily do it mentally. And what property did we use? We used the commutative property. You use the commutative property a lot. We just never really talk about it. But whenever we switch the order, we are using the commutative property. Now you can also use the distributive property to simplify some of these down. So the next ones that we're going to look at, and the last part of this section, is just using the distributive property. That's the last part that we have to work with here. Okay, the distributive property, we distribute or we push numbers or a negative sign through. So when we push something through, we distribute it, okay? And when we use our distributive property, I always like to draw arrows. So let's use these to solve out and simplify these down. So we're going to be using the distributive property. Let's use minus 4 times 3x minus 8y. How would we use the distributive property here? When we use our distributive property, we distribute or we push it through that negative 4. So the negative 4 is out in front of the parentheses. So our distributive property says we distribute or we push it through. And then we multiply. Now watch your signs. Whenever we have a negative, I like to circle it so we don't accidentally lose that negative sign. So when I distribute that negative 4 through, negative 4, we're multiplying here, negative 4 times a 3x, that makes it a minus 12x, and negative 4 times negative 8. Negative times a negative makes it a positive, and 4 times 8 makes it a 32. And what variable do we have attached? Y. Let's try several more of these to make sure we understand how to use the distributive property. How would we use the distributive property here? Very similar. We distribute that 3 through. In this case, that 3 is positive, bless you. And so we can just distribute it through. 3 times that 6, that makes it a 18. 3 times a negative 9. 3 times a negative 9, that makes it a negative 27. And that's going to be a negative 27y. So do you see how we're using our distributive property here? We just distribute. We push that number through. You can also use the distributive property when you just have a negative in front. How would you use the distributive property here? Well, when we look at this one, what do we have in front? We have a negative, and so that negative gets pushed or distributed through each part. And when we push or distribute through that negative, what happens to my signs? They're going to switch. So a negative times a positive 4t, well, that makes it a minus 4t. Negative and negative makes it a positive 5s. And negative and positive makes it a negative 7. Yeah. And what question did we have?
Is that an S on your 5?
Yes, that's an S there. Sorry, I tried to put the lines in, so you see that's an S. Here is the question that I have for you. Why can we not put the 4t and the 5s together? Why cannot those not be combined together? Right, they're different variables. And we're going to cover that more in greater detail in 1.7 when we talk about like and unlike terms. But what we're doing here is we're just distributing that negative through, or we're distributing that 3 through, or in this case, the negative 4. That is using now the distributive property. Let's do one with a fraction, just kind of like what you got on question 2. But we'll do one that's a little bit different. Again, we're going to use the distributive property. And then we'll take a short break. And I'll put a fraction up front. How about we have 8/7 times, how about, let's make it similar. How about 49y plus 49x? So I want you to use the distributive property here. Now, when we use the distributive property, if we have fractions, don't make them harder than they need to be. If we have fractions, we'll write them over to the side. But we're going to be using our distributive property. So we're multiplying here. And so what are we going to distribute through? We have 8/7, and we're going to multiply that by 49y. Now let's make it easier on ourselves, so let's make that a 49 over 1. We're multiplying. We can do each one individually. Now don't make this more difficult. When we multiply, what can we do with our numbers? We can cross what? Cancel. So that 49 and that 7 can cancel. And now we have an 8 times 7. Well, 8 times 7, that is a 56. And what variable is still left with it? Y. So that's going to be 56y. What about the x part? Same thing. We have 8/7. We're going to multiply that by 49x. We'll make that over 1. We can cancel out again the 49s, and that leaves you with a 7 and a 1. Multiplying, that gives you 56x. And that is going to be very, very similar to question 2. Okay, so let's go through and talk about our homework to make sure we've covered everything. Then we'll take a short break. We'll come back and we'll look at the next section. So let's make sure we've covered everything. Question 1, add them together. Use a commutative property to rewrite them, or just use a calculator. It doesn't matter, just add them together. Question 2, we just did that one. Very, very similar. We use different numbers, but the same concept. Question 3, rewrite them if you need to. Question 4 is use the distributive property. So distribute that 3 through. Draw your arrows and distribute that 3 through. Choose the one that's equivalent here. Let's talk about 5. What are we doing on question 5? We've got a 1 out in front, right? And what happens when we take 1 that's out in front times anything else? Does it change it? No. So what would that answer for number 5 be? It would be answer B. Why? Because when you multiply 1 times anything, does it change it at all? No. That's what I'm wanting on that one. Question 6. We've talked about that. Okay. Question 7. You need to fill in the blank and then tell me what property is being used. What's going here? We have 5, 12, and 9. We've got the 5 and we've got the 9. What's going to go in our blank? 12. Just so you understand that, what property would that be? Okay, what are we doing? Okay, commutative would mean we switch the order. Let's look at our numbers. We have a 5, 12, and 9, right? What did we change? What's the difference between the left-hand side and the right-hand side? The parentheses, right? When you change the parentheses, what property is that? Associative. So this would be the associative property. And a lot of times students get confused with these. All you have to remember is order, commutative. When you switch the parentheses, associative. What about the identity? What is an identity? Identity means they're the same. So identity would mean adding 0 or multiplying by 1. What about the inverse? Inverse would mean they're the same but opposite in signs, right? So 9 and -9. Or something like, let's say 8. The inverse of 8, multiplicative inverse would be 1/8, right? So either they're reciprocal, flipped over, or they're opposites in signs. That's the inverse. Identity means they're the same, so adding 0 doesn't change it, or multiplying by 1 doesn't change it. 8 and 9, we've talked about those. Those are just distributing the negative through. 10 is multiplying. Okay. 11, what one would that be? Okay, why would that be inverse? When we work with the inverse, right, it's either equals 0 or it equals 1. What are we doing? Okay, we're multiplying something by 1. When we multiply something by 1, does it change it? No. So 11 would be what? Would be identity, because we're multiplying it by 1. 12 and 13, we're distributing negatives through. So that's using the distributive property. So just distribute the negative through. That's going to switch your signs. Question 14. What would question 14 be? Which one of those? Yep, it would be commutative, wouldn't it? Why would it be commutative? All we did was we changed the what? Order. That is it. So 14 would be commutative. 15 is just using that sum to rewrite things using the commutative property. You can do that one. Okay. Question 16.
Is it commutative or commutative? Is there any N in there?
No, it's. Yep, sorry about that. It's commutative.
Sorry,
So,
I just, like,
no
I'm
problem.
confusing myself.
Yep, no problem with that. It's commutative. Commutative means the order.
Because I wrote it with
Yeah,
an
it's
N
it's
first,
easy to do
and
that.
You wrote it with no N, and then you wrote it with an N.
Sorry about. I didn't mean to write with the N. It's yep. There's no N in there. Sorry about that. Okay, so commutative. So that just means order. There's only one of them like that. So if it starts to see, it means you're working with the order. Okay. So what about 16? Oh yeah. No problem. Not a problem at all. Sometimes I look at things and I say the wrong thing. So what about 16? Any idea which one would be equivalent here? Okay, it would be, let's talk about what we've got here. Okay, we've got the parentheses. Now, normally, you would be distributing from left to right, but you can also distribute from right to left. You can do that. You don't normally do it that way, but you can. So if you distributed that way, what would it give you now? Or you can switch the order around, either one. In this case, you could distribute it through, or you could switch the order. If you switch the order, it would look like it would be what? A, because you can move that to the front, or you can distribute it through. Either way. In this case, the only one that matches up is when we just simply did what? Moved it to the front. These are the same. You can either distribute from behind, or you can move it to the front and distribute. Either way is the same. So the one that's going to be the same is going to be answer what? A, because you can move that 3y squared to the front and use the distributive property. Question 17 is just using your sums. And we can do those, grouping things together. Question 18. is there an associative property for both addition? Okay, sorry, there is an associative property for both addition and multiplication. Is there an associative property for subtraction? Have we ever used subtraction at all in any of these properties? When we talk about the order, have we ever dealt with any negatives at all? Hardly. No. So is there one for the associative property for subtraction? No, right? It only works for addition. So there is none. Sorry, I have to stay on 18 as there's none. There's no property for subtraction. They only work for addition. When you look at your associative property, associative means you switch the groupings around and they're positive numbers, so we don't work with subtraction at all. That would change it and that would make them different. What about 19 here? Which property would that one be? It says use the commutative or the associative property to complete it. What would go here? -3, right? Okay, and what property did I use here? Look at the left and compare it to the right-hand side. Which one? Am I switching the order? Yes, because this one is -3 times 1, right? What's the other one? 1 times what? -3. So we are working with the order. And so when we work with the order, that's that commutative property. Right? Because that's order. All we did was we switched the order. Bless you. Last one that we'll look at before we take a short break is question 20. Let's look at our multiple choice answers here. Which one's going to be equivalent to this? Do you have any idea which one it would be? Okay. It's not going to be A. Let's see why A is not the correct answer. If I use the distributive property to check, they should be the same. So if I use the distributive property here, what would that give me? That would give me 12x plus 9y. Well, what do I want it to be? 12x plus what? 3y. So it's not A, is it? Yep, B is going to work because that gives you 3 times 4 is a 12x. 3 times y is a 3y. Why does C not work? C wouldn't work. Why not? Because when we distribute, 3 times 9 is a 27x in this case. 3 times y, that's a 3y. That's not what we want. And that one doesn't look anything like it at all, does it? So the only one that fits there is going to be answer what? B. Okay, let's take a short break. We'll come back and we'll look at the next section. So let's meet back here at about, how about 10:05? So let's meet back here at about 10:05 and we'll look at the next section.